Welcome to this video assessment. Topic of this assessment is pointers. Okay, so as we know, every variable we declare has a location in memory, and every location in memory has an address. The pointer is a variable whose value is the address of another variable. Okay, so that's why they're called pointers, because they point to the address of other variables. Okay, so some tasks can only be performed using pointers, such as changing the value of variables passed into a function. And like any other variable, you must declare your pointer before using it. Okay, so here's just a simple program that I wrote to demonstrate the usage of pointers. You can see I have a couple function prototypes up here at the top. First one is just to change score. The second one is to add 10 to an array. Okay, so here we are. Here's the first pointer I've declared. When you declare a pointer, you want to use the asterisk. All right, that's the symbol for pointers. Also, when you first declare a pointer, it's a good idea to set it equal to null. That's effectively setting it equal to 0. And the reason for that is because when you have pointers pointing to random locations in memory, things could start to get out of whack and not work quite right. Okay, so it's always a good idea to set your pointer equal to null at the start. Okay, so the next line I set it equal to this variable that I just created up here, score. Alright, now I'm going to run this program and just show you that first we're going to print out the address. Notice when you're printing using a pointer, if you want to print the address, you don't need to use the ampersand sign. It's already got the value of an address. Okay, and then if you want to print the value that's at the address, you use the asterisk or the dereference operator. Okay, so here we go. I'll just run this really quick. As you can see, the pointer is pointing to this address, and the value is pointing to the value, which is 82. Okay, the next part of this, I wanted to show you how to make changes to variables within a function and have that change actually stay in effect. Actually change the value of the variable outside of the function too. Okay, so as you can see here, I call this change score function on our variable score, and what it does is change the score to, change the score to 92. That's all it does. Okay, so when I move on in the program, you will see that it's actually not going to change the value, and I'll tell you the reason why after. Okay, so new value of score is still 82, and the reason for that is because we're not passing our value in by reference. We're passing it in by value. And to change that is a small change. You use the dereference operator in the function itself. And then when you're passing in the value, you pass it in by reference, which means you're going to pass in the address in memory to the function. Okay, a couple more little things to change. You want to put the dereference operator in your function definition as well. And then to make sure we're using pointers so that it will actually change the value, add the dereference operator there as well. Okay, so now when I rerun this program, it's going to change it. Okay, so it's 82 before, now it's gone already through the change score function, and now when I print it out afterward, it will be 92. So you can see the new score is now 92. Alright, and then the next part of pointers, I wanted to show you how to use pointers with arrays. Okay, so here I've declared an array of scores. It's got four scores in there, and then I'm going to again pass the variable, which in this case is an array, into the function. And the key here is with arrays, when you are passing them into a function, you don't need the ampersand sign because the way arrays work is they're already a pointer to their address in memory. So if you have it in this notation, that's a pointer to its address. This notation is, and so is this notation. So any one of those notations will work because it's working as a pointer. Okay, so we'll go ahead and continue. We'll see that the function add10 array will add 10, and that is down here. You can see we're passing it in by reference, and then we have the array element is equal to itself plus 10. Okay. And then you can see here that I printed out the value of the array element using array notation. I printed out the address of the element using pointer notation, and I printed out the value of each element using pointer notation also. You can see that each value has gone up by 10. See, it was 72 before, now 82, 84, 92. Alright, and right here we have a little pointer arithmetic. Because pointers point to addresses in memory, you can move them from address to address, and that's called pointer arithmetic. Okay, so just using the increment operator like that will move it to the next location. And I have the next part of the program is also to show some pointer arithmetic. Okay, so I'll go ahead and run that now just to show you. Okay, so this part here, we had reset the pointer. We moved it to point at array scores, and I forgot to mention I had moved it to point at array scores before, and then we incremented the pointer so it was pointing at a different location. So now I'm going to reset it again to point at the beginning of array scores. So yeah, basically we declared a variable total, it's equal to 0, and then we said total is equal to total plus the value that is at the pointer that is the value that's at the location the pointer is pointing to, and then we increment the pointer one location each time. And you could also use the decrement operator for this. I would say just be careful using pointer notation. This is why people are scared of it, because you can start pointing to locations in memory that you haven't assigned any values to, and when that happens you will start returning different data types that you didn't mean to, and that will cause a lot of problems. Alright, that's all I have on pointers. Thank you for watching this video.